Hi everyone and welcome back to another video. In the last video we discussed what is a polynomial and how we can identify a polynomial, also what is a zero of a polynomial. In this video we are going to discuss the relationship between zeros and coefficients of a polynomial. So the concept of zeros of a polynomial we are going to take further ahead. Okay, let's start. Before looking into the relation between zeros and coefficient of a polynomial, we must have an idea about these three, right? The first one that you are familiar, okay, that is a polynomial in degree 1, then we can call this one as linear polynomial. The second one, this is a polynomial in degree 2. We have already discussed what is a degree in the previous session, right? So here degree means the highest power of the variable. Highest power of the variable here, it is 2. So we can call this one as quadratic polynomial. And the third one, here the highest power is 3. Okay, so we can call this one cubic polynomial. So there are three basic forms are there, right? Linear polynomial, quadratic polynomial and cubic polynomial. Okay, when we talk about a relationship between zeros and coefficient, we are going to stick with this one. This one is important for us. We are going to discuss only about quadratic polynomial. So we will find the zeros of quadratic polynomial and also we will find the relation between zeros and coefficient of the polynomial, right? This cubic polynomial, this is given inside the textbook, but exam point of view, this one is not important. We are not going to discuss about this one. We are only sticking on this one, that is quadratic polynomial. We want only the zeros of quadratic polynomial, also the relationship between the zeros and coefficients of the quadratic polynomial. Okay, I hope you understood this. Here we have a quadratic polynomial, right? 6x square minus x minus 2. So we can find the zeros of this polynomial. For that, let's equate this polynomial with 0, right? 6x square minus x minus 2, that is equal to 0. Here for finding the 0, just factorize this. Okay, how we will factorize? By splitting the middle term. So we can split the middle term. Product is minus 12, right? 6 and 2, that is minus 12. Also while you are adding those numbers, you must get minus 1, right? So 6x square, let me take minus 4x plus 3x minus 2 is equal to 0. Look at this, minus 4 plus 3. Minus 4 plus 3, that is minus 1, right? At the same time, 6 into minus 2, that is same. There is no change in that, right? Now let's take the common factor outside. Here the common factor is 2x. So 2x outside, remaining is x, and 2 outside, remaining 3. 3x minus, here 2 outside, then 2, okay, plus here also same, 3x minus 2 is equal to 0. Now factor outside, that is 3x minus 2, okay, outside, remaining in this term, that is 2x plus in this one nothing else 1, okay, is equal to 0. Look, product of two numbers, that is equal to 0. While we are multiplying two numbers, we are getting 0. What we can understand from that? One of these numbers is 0, right? So there are two possibilities. Either this number can be 0, then 0 into this 0, okay. Otherwise, second one can be 0, second one 2x plus 1 can be 0, then also 0 into some number, that will give always 0. So we don't know which one is 0. So let's assume 3x minus 2, that is equal to 0. This is the first option, it can be possible, right? Then second one, 2x plus 1, 2x plus 1, that is also equal to 0. We equated both factors with 0. Right, now we got 3x is equal to 2 and x is equal to 2 by 3. At the same time here, right? So this is 2x is equal to minus 1, then x is equal to minus 1 by 2. So here we got two numbers, x is equal to 2 by 3 and another one x is equal to minus 1 by 2. So these are the zeros of the polynomial. You can verify this. If you substitute this number in place of x in the polynomial, then definitely you will get 0. Same manner here also, minus 1 by 2, if you substitute in the polynomial, then you are going to obtain 0. Now, let's imagine this value, that is a Greek letter, that is alpha. Okay, alpha is equal to 2 by 3. And the second 0, that is we can consider as beta, beta is equal to minus 1 by 2. So, these are two zeros. So, we are imagining or we are calling the zeros by two letters, which are they, alpha and beta. Now, we obtain the zeros. Okay, so these are our zeros. First one 2 by 3, another one minus 1 by 2. Now, relationship between zeros and coefficients. Coefficient means these are the coefficient, right? Here 1, nothing else, and here this is the constant term. This is a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, right? As we mentioned before, right? This is the polynomial. Okay, here what we are going to do, we are going to establish a relation between a, b, c and alpha, beta. Okay, so for that, let's find first sum of zeros. Sum of zeros. What is the sum of these zeros? For that, first 0 we can consider alpha plus second 0, that is beta. So, there are two zeros. First 0, that is alpha value, that is 2 by 3. Okay, 2 by 3 plus minus 1 by 2, right? Plus minus 1 by 2. This is the sum of the zeros. Let's add these numbers. 2 by 3 plus minus 1 by 2, 1 by 6. By LCM, that is 1 by 6, right? Now, let's take the product of the numbers, right? Product of the numbers, alpha, beta. This is product. Product of the number alpha times beta. Okay, alpha, that is 2 by 3, that is again 2 by 3 into here beta, that is minus 1 by 2, multiplying with minus 1 by 2. Okay, now multiplying, in this case you are going to get minus 2 divided by 6. Minus 2 divided by 6. So, what we did, first we obtained sum of the zeros, second product of the zeros, right? Sum of the 0 alpha plus beta, that is 1 by 6 we got, and alpha beta, the product of the zeros, that we got minus 2 by 6. Okay, now clear observation, right? Look at this. This is that 6, that is the coefficient of x square, right? That is this is the coefficient of x square. Okay, we can write that is equal to, right, coefficient of x square. And look at this one. This one, look carefully. The coefficient of x. What is the coefficient of x here? The coefficient of x is minus 1, right? This one, that is 1 by 6. This one we can write minus of minus 1 divided by 6. This one we can write minus of minus 1 divided by 6, right? So, what is this minus of minus 1? What is minus 1? Minus 1 is the coefficient of x term, right? So, we can write that this is minus of coefficient of x of x. So, minus coefficient of x divided by coefficient of x square. Similar manner, look at this. Minus 2. What is minus 2? This is the minus 2, the last term. The last term without any variable, that is called a constant. Constant. Right? Constant divided by. Look at the denominator. Here also the denominator is 6. Already we mentioned 6 is the coefficient of x square, right? So, we can write that coefficient of x square. So, this is the relation between zeros and coefficients, right? sum of the zeros alpha plus beta, that is equal to minus coefficient of x divided by coefficient of x square. This is the first one. And second one, that is product of the zeros. Product of the zeros, that is equal to constant term divided by coefficient of x square. These are the relation between zeros and coefficient. Okay, you can explain, instead of writing this much, we can represent little more easily. Look at this, alpha plus beta, that is equal to, look at the general form. General form is ax square plus bx plus c, right? So general form, if you know, then you can write minus is present, then coefficient of x in the general form is b, okay, divided by, then coefficient of x square, that is a, okay, minus b by a. Now the similar manner we can write alpha beta is equal to constant term we represent here by c, right? So c over and the coefficient of x square is the same, that is a. So this way, either you can use this form or this form. Okay, this is easy to remember, but the fact is same, right? Here we are representing using the variables b, a and c. But more than these letters, you must understand what is this letters, right? What is a? A is the coefficient of x square, b the coefficient of x, and c is the constant term, right? So this is the relation alpha plus beta, sum of the zeros, that is minus b by a, and product of the zero, that is c by a. So this is the relation between zeros and coefficients of a polynomial. These are coefficients, right? These are zeros. Okay, find the zeros of the polynomial. Find the zeros of this polynomial. Okay, you know how to find the zeros of the polynomial, and verify the relationship between zeros and coefficients. So two questions are there. Okay, so in this polynomial, first we want to obtain the zeros. Soon after that, you just want to verify the relationship between the zeros and a coefficient. So we already know that alpha plus beta, that is equal to minus b by a, and alpha beta is equal to c by a. So is this correct or not, that we must verify. Okay, so that is, for that let's find the zeros first here, right? X square plus 7x plus 12, that is equal to 0. Just split the middle term, x square, product is 12, right? So we can write plus 4x plus 3x, 4 3s are 12, also adding, while adding 4 plus 3, that is 7, plus 12, that is equal to 0. Now take the common factor outside. Here common factor is x plus 4, and here the common factor is 3, and x plus 4, that is equal to 0. Now x plus 4, that is common outside, remaining is x plus 3, that is equal to 0. As I said before, the product of two numbers is 0, which means the first one can be 0 or second one can be 0, right? X plus 4, that is equal to 0, or x plus 3, that is equal to 0. So first option, x is equal to minus 4 and x is equal to minus 3. Okay, so this question we got these two zeros. Now this is a very good example to verify our previous expression. The previous expression, sum of the zero is minus b by a or not, that we can verify. Okay, so how we can verify that? Just take alpha plus beta. Here we can write alpha is equal to minus 4 and beta is equal to minus 3. So now we can verify for that. First of all, sum, right? Sum alpha plus beta. So the alpha plus beta, okay, alpha, that is minus 4 plus beta, that is minus 3, total minus 7. So we got the sum is minus 7. Okay, now alpha plus beta, that is equal to minus b by a. Okay, so for that let's verify minus b by a. Minus b by a, what is that? Okay, the coefficient of x, that is called b. Okay, this is b and the coefficient of this, in this case x square, nothing else is present, so this is 1. Okay, this is your value a, and here one term without any variable, that is called our constant, including the sign, right, including the sign. So these are the values of a, b and c. Okay, let's try this. Minus of b value is 7. Here also including sign, while you are considering the coefficient you must take including the sign. Okay, so minus of, this is a plus 7 divided by a is that is 1, so we got minus 7. So what we got, that implies alpha plus beta, that is equal to minus b by a. Verified, first one. This both is equal to minus 7. We could verify the first one. Now look at the product. Okay, so we have the product. For that, alpha beta, the first one, that is minus 4. Okay, minus 4 in time, multiplying with minus 3, right, minus 3. So what we got here, plus 12. Okay, now that is equal to c by a, that we want to verify, right. So c by a, okay, c by a, c, that is the constant term, that is 12, divided by a, that is 1, so that is equal to 12. So alpha beta is equal to c by a, that is equal to 12 in this case, so we could verify, right. Instead of writing b and a, we can write here b means the coefficient of x and a the coefficient of x square. Similar manner here, product is equal to c by a. Instead of writing c, you can write constant term divided by a, the coefficient of x square. Okay, so in the previous example we developed this expression, and now in this examples we could verify that. Okay, so this is most expecting question from exam point of view. Okay, so this is a very important type of question. Find the zeros of the polynomial. So we found that, and next one, verify the relationship between zeros and coefficient of the polynomial. So for that, these expressions we must verify. Okay, another example, p of x is equal to x square minus 9. This is a quadratic polynomial because it has a x square term, so it is clearly a quadratic polynomial. So let's verify this. Okay, so for that, first of all we can find the zeros of the polynomial. Okay, zeros of the polynomial. For that, let me equate it, x square minus 9, that is equal to 0. Here just apply a square minus b square identity. Okay, we can write it as x square minus 3 square, that is equal to 0. We can write this one as x minus 3 into x plus 3, that is equal to 0. Okay, now x minus 3 into x plus 3 is equal to 0, which means x minus 3 can be equal to 0, x plus 3 is equal to 0. So x is equal to 3 or x is equal to minus 3. So alpha is equal to 3 and beta is equal to beta is equal to minus 3. Instead of this, you can use another method, right? How it is, instead of this one you can write x square minus 9 equal to 0. Then x square is equal to 9. So x is equal to root of 9. So x is equal to root 9. In the previous part we discussed root, while we are considering the square root of any number, in this year onwards we are considering this one as plus or minus 3. 9 root is 3. So here in this year we must take plus or minus 3. Okay, so instead of doing this, simply if you take x is equal to 3, then you are not going to complete the solution. So anyway, we got here x is equal to 3 and x is equal to minus 3 to alpha and beta. Okay, now verifying the relation, is it correct or not? Okay, for that, sum of the zeros, alpha plus beta. alpha plus beta, that is in this case that is alpha plus beta 3 plus minus 3, that is equal to 0, right. Now alpha plus beta is equal to minus b by a, minus b by a. Is it 0 or not? Okay, minus b by a, coefficient of b means coefficient of x, right. We have the general form, right, ax square plus bx plus c. The coefficient along with x square, that we can call here nothing else, so that is a. The constant term without any variable, this is c, is altogether c. There is no b, right, no x term present here, which means the b is 0 in this case. In this case b is 0. So here we can write 0 divided by a. A is whatever, no problem, because already numerator is 0, so we got 0. So what we could understand here, alpha plus beta is equal to minus b by a, that is equal to 0 in this case. Now let's consider the product, alpha beta. For that 3 times of beta, that is minus 3, that is equal to minus 9, plus time plus multiplying with minus number, right. So that is minus 9. Now verify c by a. What is c here? C already that is constant term, that is minus 9 along with sign. We are carrying along with sign always, okay. So minus 9 divided by a is a 1, so that is equal to minus 9. So we got alpha beta, that is equal to c by a, that is equal to minus 9. So we verified the relation between zeros and coefficient here, okay. Now consider the quadratic polynomial. P of x is equal to ax square plus bx plus c, quadratic form, okay. So this expression, I am taking a outside, okay. So I am taking a outside. Now here x square plus, here there is no a, so it will be b by a times of x plus c by a. Look, is it correct or not? How you can identify? While you are multiplying, while you are opening this bracket, you must get this expression back, right. So look, a into x square, a into b by a get cancelled and you will get bx, right. A into c by a get cancelled, you will get c. Okay, we got it, okay. So that is equal to a, okay, x square. Look at this term now, plus b by a, okay. Look this one, minus b by a, okay. Here we have plus b by a and this is minus b by a. So we can write this one as minus of minus b by a, okay, plus the c by a, similarly we can write, okay. So that is equal to a times of x square. Look, is it correct or not? Look, minus into minus, that is plus b by a, nothing else. I just rearranged here, I didn't do anything else. I just took the common factor outside and just rearranged this, okay. So look now, minus of minus b by a. What is minus b by a? That is alpha plus beta, right. So alpha, instead of this one I can write alpha plus beta. Here s is missing, so let me write that x, okay. So x plus c by a. What is c by a? C by a is alpha beta, that is equal to, in general we can write that, any constant, okay. So a is a constant, right. So this is a constant into any constant into times of x square minus sum of zeros. Here alpha plus beta means sum of zeros, okay, times of x plus product of zeros, So this is the expression of any polynomial, any quadratic polynomial. You can write in this manner: x square minus sum of zeros times of x plus product of zeros. Any of this one you can remember, right? Okay, so this instead of, in some textbooks you can, instead of writing this a, they are representing this one with a constant. In this constant they are simply representing by a constant k into x square minus sum of zeros plus product of this. So this is the another expression you should remember. So in this today's sessions, first one, alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. Also this one, any polynomial p of x, that you can write constant, some constant term into x square minus sum of zeros into x plus product. Okay, where we will use when we know the zeros of the polynomial or sum of the zeros or product of the zeros. In such situation, for finding the polynomial from zeros, using this expression you can find the polynomial. Okay, look at this example. P of x is equal to x square plus 7x plus 12. Okay, this polynomial, this is the one which we discussed just before, right? There are zeros were minus 4 and minus 3, right? Minus 4 and minus 3 were the zeros. Okay, what we are going to do here? Here, using this, we are trying to find this polynomial. Okay, so using this using this expression, we are checking whether this expression is correct or not. Okay, if this expression is correct, while you are substituting alpha and beta here, you must get the same polynomial, right? So let's try, is it possible or not? Okay, so for that, p of x is equal to k times of x square. Okay, so for that, x square itself minus alpha plus beta. So we want alpha plus beta. Okay, so for that, alpha plus beta, that is equal to minus 4 plus minus 3, that is equal to minus 7. Now alpha beta that is minus 4 times of minus 3, that is equal to 12. Okay, just substitute in the place of alpha plus beta, let's put that value, that is minus after. Remember, already one minus is present here. Okay, so keep it as it is. Okay, and minus of alpha plus beta, that is again minus 7. Okay, so that much multiplying with x plus alpha beta, that is 12. So that is equal to k times of, okay, x square minus plus 7x plus 12. Look, here we obtained the same polynomial what we have here. These both expressions are same. Here look, what is the coefficient of x square? That is 1. Here coefficient of x square, that is 1, right? K is 1. One more same kind. Sum of zeros is 4 and product is 1 by 4. Okay, we want to cast the equation, we want to find the equation. So for that, we have the form here, right? So p of x is equal to k times of x square, that is x square minus, here you no need to, in the previous example we added alpha and beta, alpha plus beta first we added, but observe here, sum of the 0 is 4. So already they said alpha plus beta is equal to 4. Product is 1 by 4, which means alpha beta is equal to 1 by 4, right? So here already you have the sum and all and product. So what we want to do, just take this alpha and place here, alpha plus beta here and place here, right? So minus already present here, minus and 4, okay, x plus alpha beta 1 by 4. Okay, now this is the form. You can take the LCM here. So that is k times of, LCM is 4x square minus 16x plus 1 all divided by 4. So all together we can write k times of 4x square minus 16x plus 1. So this is the expression. In such condition, while you are getting a fraction, then you can take the LCM, and this one you are this one you can take outside. Okay, you no need to mention k after taking LCM. It is not compulsory to mention k. If you do so, no mistake, it's correct. Okay, either you can leave here or you leave here or further solve and reach at this expression. Okay, this is the standard expression. After obtaining this expression, it is not compulsory to write the constants. Okay, so these are the two. Okay, so more examples are available in NCERT. One exercise is completely dedicated for these two ideas. Okay, first one, how to cast the equation, and second one, what is the relation between coefficient and the zero. So these both are important question from exam point of view, so you never miss it from this chapter. The most important topic is this one, so you must go for more examples and want to practice. NCERT exercise questions are important that you must do. At the same time, extra questions you must solve. So we can solve more previous year questions from this section, also indirect questions, hot questions from this section at the end of the chapter. Okay, so you must wait for that. So we can meet in another video with another topic. Till then, bye.